Hello and welcome to Computer Concepts. This is part 1 of Module 3, Computer Hardware. Let's look at the overall objectives that we're going to cover through this multi-part video. So lesson objectives overall are we're going to look at and categorize the various types of computer hardware, become familiar with input and output devices, what the difference is. Remember that some devices are both. And then how to do basic maintenance on hardware components. So let's get started with part 1. In part 1A, so I'm breaking part 1 down, the idea of getting familiar, categorizing types of computer hardware is a pretty long lecture. I want to make sure to break it down into consumable parts. So this is part 1A, if you will. We'll look at components of computer hardware and identify types of computer hardware. So the most important part of a computer is, in fact, what's called the CPU, the Central Processing Unit. Now, a lot of people think of this as the brain of the computer, and it certainly is. But there's important things to know about the CPU. Modern CPUs today tend to be multi-core, okay? Originally, we had a single core on a single chipset. Then what we did to get stronger computing powers, we put 2 of those single cores on a single motherboard, and they worked together. We still do that today in high-powered servers, but we do it with multi-core CPUs. So multi-core means that there are multiple cores working in conjunction with each other to process material. Now, normally today, we talk about this in number of bits, and we'll be talking about bits and bytes, and I'll discuss that as it pertains to the processor when we get to bits and bytes. So today, the modern core, like an i9, can have up to 8 core processors that work together, okay? So that's what we're talking about here. And what we can see here is that there's 2 main parts to a CPU. That's the control unit and the ALU, or arithmetic logic unit. So what these things do is they process true and false and open gates on the processor. They can do binary equivalency of math. They can take a binary function and know that, you know, binary number is equal to a capital A on the keyboard, for example. A CPU also has a system clock, which we'll talk about more later. That is the speed of the CPU or the CPUs. And it also has cache, which is temporary memory, where it can store information that it's processing before it takes it out to, say, RAM or virtual memory. Speaking of memory, so let's talk about computer memory. It's responsible for holding the data and programs that are being processed by the CPU. This means when we start up the computer, okay, the information goes from the secondary storage device, commonly a hard drive, okay, either a SATA hard drive these days or an SSD. We'll talk more about those. With that, those are stored in random access memory. Now, random access memory is also called the primary storage of a computer, so you might hear that. Whereas the rest of the storage tends to be secondary. It tends to be long-term, and it is non-volatile. What I mean by that is information stored in RAM, common RAM today, is volatile in the fact that if the power is removed, okay, we lose the information. So non-volatile memory does not lose its content when power is removed, whereas random access memory tends to be volatile. Turn off the power, lose the information in it. So if we haven't saved that important document, we could potentially lose it. Read-only memory, however, is permanently installed on the computer and attached to the motherboard. This is ROM. And when we think of the BIOS, or basic input operating system, that's what we're talking about. That's where it's stored. It is the operating system before the operating system. We need to have this BIOS so that we know where to load the operating system, normally again from a hard drive, into the processor to be processed and then put into RAM. So as we start up the computer, a lot of the operating system is loaded into RAM. And then when we click on, say, a browser, that application is loaded into RAM while we're using it. So that's the difference. Now, what's interesting is that ROM now, it used to be non-flashable, meaning we couldn't change it. But today we can flash our BIOS, which means we're flashing the RAM, or the ROM, excuse me, so that we can update that basic input operating system. A third type of memory when we run out of RAM is virtual memory. So if a computer runs low on RAM and swaps the contents of RAM to and from the hard drive. Now, of course, if we're talking about an SSD and we get into a virtual memory situation, it's going to run a lot faster, but swap or paging files is the area hard drives temporarily use to store that content. So the challenge, though, is if we run out of RAM, we suddenly take, let's say, a super automobile, and it becomes a Volkswagen Bug, okay? So what that means is we want to make sure we have ample memory to run the programs that we regularly run on the computer. If once in a while we're using all of our RAM, it's not a huge deal, okay? So now we're going to move on to input and output devices. Now, when we think of these, it communicates instructions and commands to a computer, and we're going to talk more about these on the next screen. Output, of course, conveys information. And the thing is, with technology today, this idea of input and output has changed. In the basic computer, input was the keyboard, and then it became the keyboard and mouse. Now input is the stylus, it's the scanner, it's the microphone, where we can literally talk to the computer. It may even be webcam. Output devices back then were monochrome monitors, 2-colored, and a printer, and that was it. But today we have full color, 65,000 colors, touch screens that we display, speakers, headphones, projectors. We have a lot of different input and output devices. So to back up real quick, just to cover RAM a little bit more, dynamic RAM, you have this chart. What I would suggest is I'm not going to spend the time going through this chart. I suggest you pause the video, read the chart, and understand the difference between dynamic and static and magnetopricissive, I can never say that word, and flash. Now, I do want to cover flash because flash memory is really being used today for secondary storage. This is an array of flash memory is what is combined to make solid state drives, which are the replacement for the spinny disks, called SATA serial ATA drives that we're used to in computers. They can literally take a 10-year-old computer, if it can support SSD, which a lot of them do, put in an SSD, and it is like having a phenomenally brand new computer. Now, we also see flash memory used in our phones. For example, SD-RAM, micro SD cards. So SD, you see that there, right? Micro SD cards, and then, of course, flash within the phones and electronic devices. Storage devices. So again, we talked about RAM and ROM being sort of primary. RAM is what we think of as primary. Secondary memory, if you will, also called secondary storage, would be the hard drive. It might be a flash drive. So here's flash memory. It might be a solid state drive. Okay, floppy drives or optical discs. The floppy drives, of course, man, those are history. Optical discs are going away. We're really looking at SSD. We're looking at flash. And don't forget, we'll talk about this too, we're looking at cloud storage as a secondary long-term storage of our components. So, folks, that's the end of Part 1A. In Part 1B, we will discuss the following topics: how computers represent data, benefits of internal, external storage, getting more into storage, pros and cons of different types of computers, and then what we need to consider when we're purchasing a computer. Folks, most people that can purchase a computer for their own personal use tend to spend about 30 to 35% more than they'll ever use within the computer. Until Part B, I'll see you then.